Students, in this class I am going to explain about Intel 8279 programmable keyboard and display controller, which we are going to interface with this 8086 microprocessor. So here 8279 is a keyboard or a display controller which is used to control the keyboard and display by using the 8086 commands and the ALP program, which is written under the 8086 microprocessor. So 8279 is one of the IC which is used to tell the CPU that the key is pressed and key is detected. This eliminates the need of software code. So there is no another software coding commands. We are telling to the CPU someone is pressing the key and we have to handle that keyboard and we have to handle that input. So we are using this 8279 for interfacing with the CPU by the keyboard. That means we are doing input that will be taken by the CPU and execute that keyboard handling functions. So this is a feature, the interrupt output of 8279 can be used to tell the CPU that the key press is detected. This eliminates the need of software coding. Okay, so this is the features. So this is a software keyboard. We are implementing pin diagram for 8279. So which is used to interface 8086 to this 8279 by giving the input by using the keyboard. Whenever we are pressing the keyboard, this 8279 recognize that whichever they are giving the input, and it tells the 8279 someone is pressing key to the CPU, then CPU will respond according to that. So 8279 is IC in the pin configuration, and this is also pin configuration but in a short more logical form. So here the 8279 keyboard interface and the display interface. So it is these IC is used for keyboard interfacing and keyboard and display interfacing with the 8086 microprocessor. So these are the digital binary inputs or outputs. So digital binary inputs, we are pressing the keyboard. It is in form of digital inputs. That means called as a digital binary, so DB0 to DB7. We have an 8 inputs from DB0 to DB7. So digital bits. And we have an 8 outputs. B0 to B3 and A0 to A3. Then we have an scan lines for scanning the input, which we are giving from the input pins DB0 to DB1 up to DB7. There are standard lines to scan the input SL0 to SL3, and we have to row low. That means have rows from L0 to L4 and L7. That means 8 pins. Power supply DCC, and then CS bar for selecting the chip and the address A. So for reset and IR interrupt request command, the drop. See here, this is the pin diagram. This is a logical symbol for the 8279. This is a logic symbol 8279. So we are going to implement this logic design 8279 by using this IC. So whenever we are pressing the keyboard by using the key data, key pin from RL0 to RL7, that means our rows in the keyboard. So when you are pressing these bits from 0 to 7, then it tells to the 8279 work is to tell that someone is pressing key, informing to the 8086 microprocessor whenever we are pressing key by using rows or not at RL7. You already know in the keyboard we have rows and columns which are placing the keys. So whenever pressing keys, then 8278 informs to the 8086 microprocessor by using interrupt commands IRQ, interrupt request. That means someone is pressing key, that will tell to the 80 microprocessor 8086. Here we are interfacing this 8279 to the 8086 microprocessor. That means here mentioning a CPU interface. That means CPU is having CPU's interface to this side. Whenever we are pressing key, then by using IRQ, interrupt request command, it will tells 8279 tells to the 8086 microprocessor. Then 8086 microprocessor execute the operation which was produced by the user. Then that execution, what is the output? That output is given to the 8279 by using read command and data bus. That means a data bus, we have an data pins DB0 to DB7. By using the data bus, the information which is executed by the 8086 microprocessor is given to this 8279 IC by using data bus DB0 to DB7. Then whenever chip select is 0, that means 8279 is in the operation. The data bus is having the address lines A0 here, and to erase the all registers, we press reset and the clock signal. So for right operation it will be 0. What is the operation? Is given by the execute by the 8086 microprocessor is given at this stage a display data. That means output A0 to 3 and output B0 to 3. That means whatever the input we have pressed, that is given by the 8279, and 8279 informed to the 8086 microprocessor by using data buses, the IRQ commands, then execute by the 8086 microprocessor whichever given by the user. Then that output will be given to this 8279. Then 8279 given as an output display to the all. Okay, see here we already using that keyboard daily keyboard by pressing 1, 2 like that, or A, B, C, whatever the inputs we are giving. That operation is run by these 8086, and whatever the output is displayed is displayed in the display data. That means displaying output LCD or LED monitor, whatever it may be, we are using. So here the only use of this 8278 is someone is pressing the key and someone is asking the output by giving the input, tells to the CPU someone is pressing the key. That is the job of I8279. That's it. And these are the CPU interfacing pins at DB0 to DB7. The data and the command word to and from a CPU are transferred on these lines, and a read bar and write bar. These input pins enable the data buffer to receive or send our data bus. For receiving the data, for sending the data, we are using read and write commands, and the CS. CS is a low on these pins. Why? Because it is a low pin, low enable pin. 8279 for normal read and write operations. Otherwise, it remains high. Whenever there is an operation performed in the 8278, this pin is low. Otherwise, it is high. A0 address lines. A0 is 1. Transfer of command or status information. A0 is 0. Transfer of data. Whenever A0 is 1, the 8259 transfer status or address to the 8086 microprocessor. Whenever A0 is 0, it transfers the data. Okay. And See, read set. The high on this indicates a reset of 8279. Whenever we are reset is 1, the registers present in the 8279 will be erasable, and the clock generates the internal timing required for 8279, and IRQ gives high when there is a data in FIFO sensor RAM which generate an interrupt to CPU. It goes high when there is a data in FIFO. That means there is a data in the FIFO server. When it goes high, whenever there is a data in FIFO server RAM which generate interrupt to CPU. Whenever the data in the RAM, it generates the interrupt to CPU to tell that CPU that someone is asking some data. It will tell to the CPU by using the IRQ command. Whenever the IRQ is high, it tells that someone is asking the input or someone is asking that some operation whenever the data in the FIFO server. Okay, so SL0 to SL3 scan lines. It is used to scan the keyboard matrix and display digits. Okay, so scan lines SL0 to SL3 scan lines are used to scan the keyboard matrix and display digits. See here, we have 8279 a programmable keyboard and a display controller. See here, we have data buffers and input output control and FIFO sensor RAM and status and internal 8-bit data bus and the display address registers, display RAM and control and timing registers, FIFO sensor RAM and the keyboard debox and control, return, scan counter, timing and control unit, display registers. See here, these are the blocks of 8279 programmable controller. Okay, so see here, data buffers which are used to transfer the data from 8259 to 8086 microprocessor, and input output controller for input and output read and write transactions. We are using the input output control. FIFO and the sensor RAM status. That means whenever pressing the key, that data will be stored in the FIFO RAM. Okay. So whenever the keyboard is bounced under control, that means whenever we are pressing key like 1, 2, whatever it may be, that will be stored in the FIFO. That means first in first order. Whatever the first we are pressing, that will be going first out. Okay. So and the FIFO sensor RAM. So that is the FIFO sensor RAM. And the for operations we have using the timers and the controlling the operations in the architecture. We have timing registers and these are the written, and whatever the pressed that will be scanned by the scan counter for displaying the data, for receiving the data, and the first scan counter we have a timing and the control unit for maintain what the time the concept counting the time, so by using timers. And display registers, whatever the registers, whatever we are pressing keyboard, that will be displayed in the display register for storing of an inputs, whatever the outputs coming from the keyboard, coming from the 8086 microprocessor, that will be stored in the display registers. And 16:8 display RAM, that means whatever the output displayed by the display unit, that will be placed on the RAM, and display address registers, whatever the output of the address, that will stored in the display address registers. So whenever we are giving the input from the keyboard which is present in the FIFO RAM, that will be that input is scanned by the scan counter, and this input is given to the 8086 microprocessor by using interrupt request command, and whatever the input is given by the user, that will be operated by the 8086 microprocessor, and that output is given to the display. That output is stored in the display RAM. for display. Okay, this is the block diagram. See here, that is we are interfacing our 8086 microprocessor to the 8279. So this is the 8086 microprocessor, and these are the pins to the 8086 microprocessor, which is connected to the 8279 by using these pins IR0, D0 to D7, read bar, write bar, reset, and the clock. So VHE bar and the A0, maximum and the minimum bar. And this is the logic, and keyboard for pressing key, and the decoders for scanning, and display unit. So the rows which are present in the keyboard present here, that will be shifted to these scanner, and by using this scanner, whatever the output, whatever the keyboard is pressed, it will detect by the scanner. And 8278 simply tells to this 8086 microprocessor keyboard is a keyboard. In the keyboard input is given, then by using the IR not command, IR quick command. So then data is transferred to the 8279 to D0 to D7 by using data bus. 8086 perform the operation and giving the output from this 8086 microprocessor by using data bus, write, reset like that. Then 8279 displays the command, displays the outputs by using out commands, display unit. This is a process. So this is the interfacing circuit of 8086 microprocessor to the 8279 programmable keyboard interface or display